So basically, we are looking at KCSE Maths Paper 1. And I'll be able to pick today, right, from Form 1. Form 1 concept here, Form 1 mathematics concept here. All right. Ladies and gentlemen, for those of you who have never seen this module before, my name is Dr. Joshua Aura. I teach at a college known as RCM College. Basically, we teach CPAs. So today I'm doing a CSR activity, corporate social responsibility activity, by coming to help our Form 1 to Form 4 students here, at least get to understand, like, how do they get an A plane in this mathematics paper. There are those short questions that you are doing even at primary level, which in this case here, we need to be able to get them right. The moment we get those things right, like fractions, equations, etc., then we'll never have issues. So, ladies and gentlemen, I would want us to start by looking at very simple questions here and reminding ourselves. So if, for example, somebody tells you to get the greatest common divisor, GCD, greatest common divisor between these two numbers, 2160 and 315. Is there anybody who can give me this answer very, very fast? Is there anybody who can give me this answer very, very fast? Anybody who can give me this answer very, very fast? They want you to get the GCD. GCD is among the very first topics in Form 1. You must have covered GCD. You must have covered LCM on your very first term. I'm 100% sure. I'm 100% sure of that. I'm 100% sure of that. So I'm giving you exactly 2 minutes to see whether there is anybody who will be able to give me this GCD. Greatest common divisor. The greatest common divisor. It was also there at primary school level. So perhaps you will need to introduce by mentioning there that GCD is the largest positive integer. GCD is the largest positive integer that divides two or more integers. It is the largest positive integer that divides two or more integers without leaving a remainder. So in this case here, there is nothing that will remain undivided. Greatest common divisor. Nothing will remain undivided. We have got, ladies and gentlemen, I can see from millimpa, 45 is correct. 45 is correct, and I like the speed. 45 is correct. So we have got various methods here that you could use to get this 45, that this student is talking about. This 45, many methods really. We could use factorization approach, isn't it? All right. We can use the tabular approach. Let's start in this case here with the tabular approach. So the tabular approach. What do we have there? Tabular approach. What do we have here? So under tabular approach, we shall have our two numbers. We have here 2160. We have here 315. So then we shall start straight away with the lowest prime number. Remember, a prime number, basically like 2 is a prime number. Because for you to get a whole number with these two, it is either you divide it by self or by what here? By 1. So this is a prime number. So but I would want to get a whole number. It is either I divide by self, which is 2 to get 1, or I divide by 1 to get, in this case here, 2. You see, a number like 4 is not a prime number. Because 4 mean I can divide 4 with this mean. If I want to get a whole number, I can divide first of all 4 with self, and I will get 1. I can come and divide this 4 in this case here by 2. You see, I get a whole number. I can come and divide this 4 by 1. You can see in this case here, really, we have got many quotients here that will be able to give us what here? A whole number. When you talk about a prime number like 5, you see 5 is a prime number. Why? Because for you to get a whole number quotient here when you divide, It is either you divide by self, which is 5, or you divide by what here, somebody? 1, to get a whole number, which is 5. So in this case here, I want the very smallest prime number that can go into this is what here, somebody? Is 2. Is 2. So then can you kindly tell me 2 goes into this how many times? Do you have your calculators? 10, 80. Somebody is giving me 1080, 1080, 1080, 1080, 1080. But now remember, ladies and gentlemen, if we go this approach, we cannot be right. Why? Because if we go this approach here, we are going to get what we call remainders, isn't it? Like now 2 can't go into this fully. So this is the approach of what here? LCM. This is the approach of LCM. So in this case here, the very smallest prime number that can go into both, is which one here? 3. The smallest prime number that can go into both fully without leaving a remainder is 3. Is 3. Is 3. So can then somebody tell me, if you take 2160 divided by 3, 2160 divided by 3, somebody must write there, know how to write there, know how to write there, know how to write there. I would really wish to see you guys writing there. If you take 2160 divided by 3, I'm being told here, it is 700 what here? 20. Thank you very much, Natasha. 720, yes. How about 315 divided by 3? 315, I have to get in this case here, somebody else confirming. I've been given, I happen to be having some students in the house here. I've been given an answer here. I've been given an answer here. So now I'm waiting for an online student to be able to tell me, hey, what is this 315 divided by 3? 315 divided by 3. Because remember GCD really, there are no leftovers. No leftovers. I would want to start in this case here with a number that will divide each one of them fully. So Millie, she's giving me 315 divided by 3. As somebody from the house here had given me, it is 105. Now, ladies and gentlemen, before I leave this smallest prime number, I have to try and see whether still 3 will be able to divide each one of them using a calculator. Let me see. Let me put 3 here. So what is 720 divided by 3? 720 divided by 3. I'm getting a very good answer here. 720 divided by 3. Natasha is giving me a figure of 240. How about 3? Is 3 able to go to 105? Oh, yes. 3 will be able to go to 105 fully. So 720 divided by 3. 720 divided by 3. I have here 240. I have here 240. And then I have what here? Somebody 35. You guys are great. So can we try 3 again? Let's try 3 again. If you try 3, what is 240 divided by 3? 80. That is very good. If we try 3, 240 divided by 3 is 80. How about 35 divided by 3? 35 divided by 3. Would I get something point? 35 divided by 3? Impossible. Thank you very much, Samson. Impossible. Impossible. Then that means that now these 3, we can no longer use it. Because if I use 3, fine, this will work out. But here I'm going to get, in this case here, decimal, I'm going to get leftovers. Remember, for GCD, we don't have leftovers. For LCM, of course, I was going to see LCM, you should be working with leftovers. So, ladies and gentlemen, then I'll be able to go to the next prime number after 3. Of course, I can see a possibility with 5. So what is 240 divided by 5? 240 divided by 5. Remember, we normally give present here. 240 divided by 48. 48 years. So we have 48. How about 35 divided by 5? 35 divided by 5. That gives me 7. 7. Now, can we try 5 again? I can't even dare try it because I know it can't go into 48 without leaving with leftovers. I can't try 5 because I know it can't for sure go to 7 or as a whole number, as a whole quotient here. So in this case here, let me try 7 because I can see 7 here. What is 48 divided by 7? Again, impossible. Impossible, right? 48 divided by 7 is impossible. So it means that we have hit our Waterloo. We can't continue with these particular prime numbers. And therefore, if that is the very end, that we don't have any common divisor between the two, then our greatest common divisor for this will be given by us multiplying this. Will be given by us multiplying this. So our greatest common divisor is. So our greatest common divisor will be 3 times 3 times 5, which gives me what here? 40. Which gives me 45. Which gives me 45. Which gives me 45. Is that okay? I'm so sure this is a method that all of us are used to. This is a method that all of us are used to. The only thing that I need to do is just to be sure that I don't get to confuse these with the LCM approach, which I'll come to. Remember that the greatest common divisor, the number that you use here has to divide both. It has to be common to both. So is that okay? You guys are not getting confirmations from you. Is that okay? Simply write there, okay, okay, or yes, or yes. Are you okay? All right, at least I can get one confirmation here from a great student called Natasha. Great, 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 great. Now, another way of doing this, although I always prefer the tabular approach, because tabular approach, you see, if, for example, you have got 3 numbers, it can work. There is this other method I normally see some students here using, that we have here 2160 method 2. And we have 2160 equals 315. Then we ask ourselves, in this case here, this 2160 divided by 315. 2160 divided by 315 equals what? 2160 divided by this 315 equals what? 6.8 something, isn't it? No, okay, you have to say there SD in the calculator, show you SD to get the answer. You have to say SD to get the answer, to see the answer. So is there somebody who's getting 6.8 something? 6.8 something. Thank you so much. Thank you so much. Please, everybody must talk to me because I would want us to be on the same page. So if I'm using this approach, then I can't talk of 0.85 because that will lead to a remainder. So normally what I do, I take just the whole number alone, which is what here? 6, which is 6. But now there is some leftover then. If that is the case, there is some leftover. So how do I get the leftover? It will be 2160 minus this 315 times 6 exactly. Don't use 6 point something. Leave alone the 6 point something. It's 6 alone. So you take 2160, 2160 minus 315 times 6. What figure are we getting there, somebody? What figure are we getting there, somebody? Please talk to me. Do you have calculators? And sure that you have a good calculator. So what is the remainder there? To get the remainder, I'm taking here 2160 minus 315 times 6. Alango is giving me 270. So the remainder is 270. The remainder is 270. Is that okay? Are we able to get the 270? Thank you so much. From there, now you go to the second step. So the second step, you are going to compare this number with this number. So we have here 315 equals 270 into something in brackets. How do you get this something in brackets? You will take 315 divided by 270, and then you write the whole number only, and don't round off. Don't round off. So like 315 divided by 270 gives me, my online audience, I'm really, really hoping you can give me answers. If you were to give me answers, then I will do a very good session for you guys. All right. Otherwise, I'll see that this is not a very good audience, and then I get myself another audience. So are you seeing 1 point something?
Yes.
So then this will be 1. Then what is the remainder? Is there somebody who is able to see the remainder? How do we get the remainder? You will take 315 minus this times this. 315 minus, because you know when this crosses over, it will be minus. So 315 minus this times this. What are we getting there, somebody? What are we getting there, somebody? 45, right? Yeah, I'm getting 45 from one student here, 45. And then, ladies and gentlemen, we shall come and go to this other step. So again, we compare this with this. We compare those two. So we have here 270 equals 45 into some brackets there. How do I get this abracadabra, this bracket here? So it will be 270 divided by 45, isn't it? Yes. Which gives me 6. 6, yes. Which gives me 6 like that. Do we have any remainder? So, and if we don't have remainder, as per the definition of GCD, that we should have a common divisor without any remainder. So the remainder here is 0, basically. No remainder. No remainder. Then this answer you've gotten here that gives you no remainder here is the GCD. Therefore, GCD equals who? 45. Are we getting the same answer with the other one? Are we getting the same answer with the other method? Mm-hmm. So the answer that you pick here now is the GCD. Is the GCD. Is the GCD. All right. So if you're together up to there, ladies and gentlemen, I'm a happy man, but I would want to see whether there are students then who will be able to give us now the least common multiple. Least common multiple. There is another method, but I believe you guys, most of you don't have this. You know, there is another method that you can come and use this kind of a calculator. And you have to tell your parents you need to buy you this kind of a calculator. It's called 82ES FX, 82ES Plus. It's a very good calculator, because you'll be able to come and use this and get factors of these 2160 and 315 automatically. So like, for example, here, you will come and do this one, you will come and do this one, you will come and do this one, you'll come and do this one, and give us the factors of 2160. Give us the factors of 2160. So factors of 2160, I'll come and write here 2160, I say equals first. And then I'll say, in this case here, there is a factor. This doesn't have a factor. Factor, it's here. So shift, factor, fact. So it gives me 2 raised to power 4 times 3 raised to power 3 times what here? Times 5. And then I'll come and punch here 315. I say equals first. And then I say shift, factor. So I'm getting here 315. I'm getting here 3 squared times 5 times who? Times 7. Times 5 times 7, like that. Times 5 times 7. Now, once you have the factors, it becomes now very easy for you to pick up the common numbers. Common numbers. Like now 7 is not common to both. I can't pick it in my GCD calculation. 2 is not common to both. I can't pick it in my GCD calculations. All right. But now, ladies and gentlemen, look at 3. 3 is common because we have 3 cubed here and 3 cubed here. We have 5 raised to power 1 here, 5 raised to power 1 here. We have those. So then come and pick, in this case here, your GCD prime factors. So the ones which are common, we have this versus this. Remember, because here you're looking at the GCD, you pick the one that has got a ceiling here, the lower ceiling. So the lower ceiling between the two, these two, I'll pick 3, the lower one is squared. Times, in this case here, I have 5, which is common, and unfortunately, both of them have raised to power what here? They have raised to power 1. So basically, I'm picking 5 raised to power 1. I can't pick 7 because it's common to both. So then if that is the case, 3 squared is 9. 9 times 5 gives me what here, somebody? Gives me 45 like that. Gives me 45 like that. But this is a method I would want us to really explore once we have our parents buying us this calculator called FX 82 ES plus. Very good calculator. It's allowed. ES plus. So between the 3 methods, you should be comfortable with all of them. And then if you allow me, ladies and gentlemen, I'll be able to take you to LCM. Can we go to LCM? the least common multiple, and please get to tell me once you're tired, because I'm so sure most of you are used to how many minutes classes? 40 only. So if we do like a 2-hour class, you guys will die. Yeah. True? True, that's supposed to be more. It's supposed to be more than one lesson. So maximum should be 45 minutes. But you can allow Mwalimu to go up to. Yes, it is allowed. It's a normal calculator. It's not like, it's a scientific calculator. It's not a programmable calculator. It's not a programmable calculator. All right, so ladies and gentlemen, in this case here, go ahead and mention their least common multiple, LCM. So for LCM then, I would want you to give me LCM of these three numbers. We have here 30, 32, and then we have 36. These three numbers. So because there are three, it's either you get the factors using a calculator, or you use a tabular approach. Use a tabular approach. So tabular approach, the smallest prime number is 2. Now here you only look, you can have remainders. You don't have to get like 2 going into each one of them. Here we are lucky. We have 2 going into each one of them. So like 30 divided by 2 is what here? 15. 32 divided by 2 is what here? Use your calculator. 16, right?
16.
Right? Is it 16?
Yeah, it's 16.
How about 36 divided by 2, the last
18.
one? 18. So we are lucky. Before we go to the next prime number, we must try and steal the lowest, 2. So if you look at, for example, 15 divided by 2, it can't give us a whole number. LCM is very, very interesting. So here, because 2 can't go into 15, we shall simply pull 15 down the way it is, isn't it? That's LCM for you. How about 16 divided by 2? 8. How about 18 divided by 2? 9. Thank you very much, Samsung person. So still I can see 2 is going into this. I like LCM so much because if 2 is going into this, I'll come and put 2 there. And then I'll be able to steal 15, will not allow these 2. But 8 allows 2 very well. So I have 4 there. 9 allows 2, no, 9. So are we together, ladies and gentlemen, up to there? Thank you very much, because I can see even Son of God has confirmed something there. So do we have this? Still 2 is good, isn't it?
Yeah.
2 is good there because there is a 4 here. LCM is very interesting. So here we have 15, we have 2 there, and then we have what? 9. Thank you so much. We still have 2. 2 has a friend here. And because we still hold on to the smallest prime number until we exhaust it fully. So we have 2 going into this, no, 15. Going into this 1, yes. And then we have what here? 9. Now 2 does not have any friend. 2 doesn't have any friend. Now we go to the next prime number, which will be what here, somebody? 3. Which will be 3. My table is quite small here. You'll allow me to continue here with this one. So we have 15, 1, and 9. So in this case here, we'll come and pick 3. 3 is the next prime number. So 3 is a friend of this because 15 divided by 3 gives me a whole number. It's not a friend of this, so we drop 1 the way it is. It is a friend of this. 3. We still have 3 here. I can't jump to 5. We still have 3 there. So then this will be 5, 1, and what here? 1. Because of 3 divided by 3.
Yes.
1, right?
Yes.
1. And then now lastly, we go to which prime number here? 5. So then this one here will end up being 1. Remember, if it's LCM, you must kill this thing to 1, 1, 1, 1. If it's LCM, you must kill this thing to 1, 1, 1, 1. Like that. And therefore, our LCM will be equal to what? Now you multiply all these numbers, 1, 2, 3, 4, 5. So this is 2 raised to 5 times 3 raised to 2 times 5, like that. So who is able to give me this LCM? Who is able to give me this LCM? 1440. Please ensure that you know how to raise in your calculator. To raise is like this. In your calculator, to raise is like this. To raise. So they're giving me a figure of 1440. Did you get it yourself? 1440. I'm getting a figure of 1440. I'm waiting for confirmations from the other students. I'm waiting for confirmations from the other students. 1440 as well. Somebody has been able to confirm this 1440. This 1440. Thanks, Mika. Thank you so much. Thank you so much. At least I can see students now who are really, the moment you know GCD and you know LCM, then you have solved most of your problems. You've solved most of your mathematical problems, really. Most of your mathematical problems will not be there at all. There are things, if you happen to be knowing very well, you can never go wrong in mathematics. Once I know this LCM and the GCD very well, I'll have solved most of my problems, because you see, you go to a question, and then these guys will tell you that we have got 3 taps. 3 taps in this case here, you are filling a tank at certain speeds. And then you'll be asked a question there. That you have got 3 clocks, 1 clock, for example, is losing 2 minutes, etc. Like, you'll be able to apply this. You'll be able to apply this. So this is a very serious thing. The other thing that I would want us to talk about as we close our chapter, it is this concept of equations. So I'm so sure equations, you have not done equations. The students who are in Form 1 year, they haven't done equations, but of course the senior students will have done equations. So I want us to look at equations, just few, and then tomorrow we shall be able to look at past paper questions from KCSE. So remember, under equations, we have like the 2 unknowns. Let's first of all start with the algebraic expressions. Algebraic expressions. We start with algebraic expressions.
It's algebraic.
All right. So if, for example, ladies and gentlemen, you are given a simple mathematics sum like this, very simple. I can normally see them in KCSE. Make this the subject of the formula. Logarithms, etc. Very easy stuff. Very easy stuff. Very easy stuff. So if, for example, you are given something like this, 5x, and I think I should now be able to give a present, 5x plus y plus 3 equals, or rather minus 3, x minus 2y plus 1. And you're told to just simplify. You're told to simplify. You're told to simplify. So is there somebody who will be able to give us the simplest form of this? The simplest form of this. You're told to simplify. That's a simple thing, simplify. So like if I'm the one doing this, the very first thing I'll do is to come and open these brackets, isn't it? So how do I open these brackets? This one, even if it had its own brackets, of course, there is no sign outside here. So it's an implied positive 1. So then this one here will be 5x plus y plus 3 minus. When we open here, this minus outside here is so powerful. It has to change the signs inside here, all of them. So like now this will become minus what here? Minus 3x, the first one, isn't it? This is minus 3 times minus 2.
Positive 6.
Positive 6y. Positive 6y. Then we have here minus 3 times plus 1. Of course, minus and a plus, minus will always take over. Minus is always a stronger reverb.
Negative 3.
Negative what here? Negative 3. Negative 3. Negative 3. Now from there, we shall put like terms together. I normally see some students, primary school, secondary school students, trying again to pull these things together. You no longer do that when you have a calculator. When you have a calculator, yours is to come and pick those terms that love each other, or you call them like terms. So like now we have 5x and the minus 3x. So you simply take 5 minus 3 because they are like terms, which gives me what here, somebody? 2x. So you ask yourselves whether this y has a like term.
Yes.
Does it?
Yes.
So it has a partner there. So it is y plus 6y,
7y.
which gives me 7y. How about this constant term? Does it have a partner?
Yes.
The constant term, does it have a partner?
Yes.
But a bad partner for that matter, who kills it? Is there somebody who is able to see here 3 minus 3?
Yes.
It is 0, isn't it?
Yes.
So then this becomes the most simplified equation. This becomes the most simplified equation. So are we together, my friends?
Yes.
The online friends, are we together really? 2x plus 7y. Thank you very much, Liam, Chris. Thank you very much. All right. All right. All right. So there are things we understand very well in this KCSE Maths paper 1. We shall be able to crash the paper in the shortest possible time. So if, for example, you are given here, just a simple question, of course, you can't get this in KCSE, but just to build up onto our knowledge and the foundation. If you're given here x plus 5 over 3 plus x minus 1 over 4, and then they want you to simply simplify. They want you to simply come and simplify this. So in this case here, I need LCM of 3 and 4. LCM of 3 and 4 is what somebody here online? 12 years. So it means that I should be able to come and take the whole of this times 12. The whole of this times what here? 12 times the LCM. So abracadabra, then this automatically will be 4, isn't it? And this going here will be 3. And then you open brackets. Well, opening brackets, we know that 4 will multiply each one of these. So it will be 4x. It will be 4x plus who? 20. Plus who? These 3 again will eat into each of these numbers inside the brackets.
Yes.
So what do we have here? Somebody we have 3x minus 3. 3x minus 3. So from there now we will come and put like terms together. So like terms together, this x, does it have?
Yes.
Oh yes. So it is 4x plus 3x.
7x.
7x. Plus, how about this 20? Does it have a partner?
Yes.
Yes. So it is 20 minus who?
3.
Minus 3. Thank you very much, Samsung. 20 minus 3. That gives me what here, somebody? 17, isn't it? That gives me 17. That gives me 17. So remember, if for example, this one here was to have like a constant number like 20 there, and then they tell us in this case to go ahead and find the value of x. Listen, if for example they are 20, so I would have multiplied this with the 12, this with the 12, and this one here with what here, somebody? 12. Because the River Jordan, things must hold on both sides of the equal. Final answer from Liam Chris there, which is very good. Liam Chris, sorry, yeah. Liam Chris, which is very good, is 7x plus what here? Plus 17. Plus 17. So, ladies and gentlemen, we started by you guys telling me that Mwalimu at a secondary school level is supposed to have our class being how long? Our class is supposed to be for how many minutes? Our class is supposed to be for how many minutes? Please be very honest there. Be very honest there. Please give me the number of minutes that your class normally takes. Yeah, I can see like one student is telling me 40 minutes, 40 minutes or 40. 40 maximum. One class is 40 minutes. One class is 40 minutes. Yes, and you can see now we are on to our 45th minute, and I would want to stop there. When we come now tomorrow, then I will be able to look at paper 1 mathematics cases and be able to show you how these particular topics you're doing in Form 1 are very important in KCSE. And that is why as a Form 1 student, for example, you are not supposed to waste even a single minute thinking that you shall recover the same in Form 2. No. Here, everything you hit while in this case here, knowing straight away on the track, you're on the track to KCSE. So please, I shall be able to meet you again tomorrow at the same time, 8:30. And most importantly, I know the weakness that we get ourselves in as Form 1 students. Number one, we think that we have a lot of time. All right. Number two, of course, we have the cultural shock issues. Like, for example, you came from a primary school, right? Where in this case here, corporal punishment was there. And now you've gone to a school where they don't beat you at all. You know, even managing that alone is an issue. Not many, because guys are used to being beaten. All right? All right. Or for example, a primary school where there was a lot of food, and now here in secondary school, there is no food. There is no food, isn't it? So it becomes an international war here. So we need to know how to manage all those cultural shocks to our advantage. Knowing that you are in that secondary school for how many years? 4, which will not be elongated at all, which is quite a short duration. All right. And of course, where we are heading to, remember we were in agrarian revolution long time ago. We went to industrial revolution. Right now, we are going to what we call knowledge revolution. Anybody will be very knowledgeable, even right now. If you are very knowledgeable, you shall become rich very, very fast. So please, you have a very big opportunity of getting, in this case here, knowledge. Don't squander that opportunity. Don't waste time. It doesn't matter the secondary school you find yourself in. What matters is practice. If it's mathematics like the ones that you've been able to do today, get, of course, after break, you simply sit somewhere and practice. You do like exactly the ones you've done, putting solutions aside, and then you get other questions which are similar colleagues, and then you tackle them. You become, in this case here, an expert in that area. That way you'll be able to get an A plane, and then of course you'll be able to go and do great courses in the university. Otherwise, given that we are going to the knowledge economy, it doesn't matter how rich your father is today. If you're not working very hard, you may easily end up being a cart pusher. We have seen it all. And there is nothing that is very, very far-fetched. So it is you, in this case, you were supposed to define what you would want to happen to you in the future. As people tell us, education is an equalizer. If in this case here you are so serious with your academics, you will end up, in this case here, amounting to somebody in the future. So I'm looking forward to seeing you tomorrow. But of course, if you're going to join my mentorship classes, then you need to be very serious, because I only mentor very serious students, not students that I teach like now here. The next thing is taking like a whole mukate, then KFC. Okay, you can eat all that, but again, with your books by the side. Because when I come tomorrow, I would want seriousness now. I would want, in this case here, to give you questions, colleagues, to try. And I always, as you know, I'll give you what here? I'll give you presents. Otherwise, I hope you have enjoyed my class. Can this mwalimu make a good secondary school teacher?
Yes.
Really?
Yes.
All right. Okay. Unfortunately, I can't be able to give you like extra time, given that I'm working. You can only rely on the classes that I teach you here, and of course, you are mwalimu's work. Because at the end of the day, ladies and gentlemen, it doesn't matter how poor you are. If you start studying today, you'll still get an A in that mathematics. You'll get an A in that mathematics. You are not late. You're not late. I wish I had the time. If I had the time, then I would have really been able to put that time to your teaching, but I'm quite busy. I only want to work and give you guys for 45 minutes, yes, 45 minutes every day. Otherwise, thank you very much. Thank you very much. Be blessed. Bye-bye. And of course, this particular video, I'll be putting it on YouTube, and I'll share the link with all of you. And then, of course, you should be able to share the same link with your colleagues in high schools. And then, of course, on YouTube, I expect you guys to promote me by subscribe. That will be very good. Thank you. Bye. See you tomorrow, same time.